Jai Hind everyone. So this is Dr. Avdhesh Gupta, professor in CSC department. Today we will discuss the topic recovery system and database management system. So basically, what is recovery? Recovery is a mechanism where we can get our data from any crash hard disks, or if any transaction failures, how can recover the database, or we can recover our records. So this is how we can identify the different methods to recover our database. So to start with the recovery system, we all know that what is failure, what is error, what is fault. Failure. It is deviation from normal execution. It means if the normal execution or normal operation is that we are inserting some command, we are deleting something. So it will not delete. It will deviate from our current operation. So it means the system fails to operate the current operation, the current operation or current command that we have initiated to a system. What is error? It is a state where there is a deviation from normal behavior. The first one, failure, deviation from normal execution, and error is the state where the deviation from normal behavior. Failure is it denied to operate the current execution, and error is a deviation. It means it's a stop. It shows a message that there is a error in this operation. You need to re-execute the command again. If the command failed to execute, then it is failure. Fault, the reason for failure. What is the reason behind this particular failure? Fault causes error, and error results failure. If there is a fault, there is a reason to failure, then it may state error, and it results in the failure of the database or any database operation. So failure classification. We can classify the failure in different ways, like for example, transaction failure, in where logical error and system errors are there. Another is system crash and disk failure. The very basics phenomena that what is transaction failure? Logical errors. It means transaction cannot complete due to some internal error condition such as bad input, data not found, or overflow. System error. The database must terminate at active transaction due to an error condition. If there is an error, then system error can generate. System crash, a power failure, like for example, power failure or any hardware or software failure. So system crash. Disk failure, it means a head crash or the similar disk failure. It means the hard disk or the storage device did not respond properly. It means disk failure, and it destroy all the part or the part of disk storage. Then it is failure, disk failure. The storage structure. We can define the storage structure in volatile, non-volatile, or stable storage. Volatile, it means it doesn't survive for system crashes. For example, main memory like RAM. Cache memory, it stores the database, is stored the operation, but not permanently. It is stored the data, is stored the addresses or the current transaction temporarily. Non-volatile, survive system crashes. Like for example, disk, tape, flash memory. Non-volatile, battery backup, RAM, but may still fail, and due to failure, it may lose data. Stable storage, any mathematical form of storage that survive all failures, and approximately by maintaining multiple copies of distinct non-volatile media. That is stable storage. The main aim of the recovery is to restore the database to the most recent consistent state. If we want to recover our database, recover our transaction, so we can recover the transaction to the most recent consistent state, so that the database must hold the consistent property. The recovery management component of the DBMS is responsible to perform recovery operations, and it is basically ensure two important purposes: atomicity and durability. Like for example, if I am saying that there are four properties of transaction: asset properties, atomicity, consistency, isolation, durability. But it ensures to most purposes atomicity and durability. Atomicity by undoing the action of the uncommitted transaction. If any transaction fails before any commit operation, then it undo the uncommitted operations or uncommitted transaction. Durability, by ensuring that action of the committed transaction survive any type of failure. It means durability. Consistency, it means if we recover the database, then its recent consistent state, we can recover the database to its recent consistent state. The most common recovery method is a log-based recovery. The most common, because in database, everything has been stored in log file. Every operation, every command has been stored in log file, and we can easily recover the database to its previous condition, to its previous consistent state by using log-based recovery or log files. So log-based recovery. The log, it is a simple file which consists of a sequence of log records. What is a log record? Log records are the syntaxes, the commands which we have executed currently. The log file contains all the commands, all the operations which we are doing on our system, and maintain a record of update activities on the database. And it also kept in stable storage in disk, in hard disk. So it is a stable storage. We can check the log file at any time. So when any transaction Ti starts, it registered itself by writing a Ti start log record. If a transaction starts, so Ti start must be there if we are maintaining log file. When Ti execute write X, if execute write X, then we can do as Ti X. X, it means the write operation on V1 and V2 is written, where V1 is the value of X before the write operation, or we can say the old value, and V2 is the new value. So X is the write operation, V1 is the old value, and V2 is the new value that is written over the V1 variable. When Ti finishes, when it complete the statement, complete the transaction, then Ti commit operation must be there to finalize the transaction, that the transaction has been committed, the transaction has been completed. And when a transaction is aborted or failed due to some problem, the log record must hold abort Ti, so that the log file must contain that the particular transaction has been started, the particular transaction has doing some operation, the particular transaction has been committed, or the particular transaction has been aborted. Like for example, consider this transaction: read modification in the value of A, write command read B, modification in the value of B, and write B. Read C, the modification in C, and the write C. We can do in this way: T0 starting of the transaction, read the value of A, value of B, and commit. The value of A and value of B, read it doesn't mean read, it means the value is updated to 1000 to 950. It means we have subtracted 50 from A. Like in this, we have subtracted 50 from A. So it means T0, it is the transaction number, and the A may 1000 is the old value and 950 is the new value. Similarly in B and similarly in C also. So when the transaction completes, it states that the T0 committed. This is another transaction. So start, do the operation, and then commit. So this is how we can share that we can say that this is the complete transaction of T0. Start, the operation, and the commit operation. So there are two approaches using log files: deferred database modification and immediate database modifications. So we will discuss these things. Let's say a small thing we will discuss here, that deferred database modification is the modification that if we are doing some transaction, so the transaction will update its value slightly after it. Like for example, first it will maintain the log file, then it update the transaction in hard disk. Immediate, it means as soon as the log file is updated, immediately the hard disk database has been updated. So deferred database is the most important role, because we have to update first log file and then the transaction. But immediate, when we are doing the online transaction or when we want to do some live transaction, then immediate database modification is required. So deferred database, first we will discuss the deferred database. All the database modifications are recorded in log file. but defer the execution of right operation of a transaction until the transaction partially commit. When the transaction is partially commit, we ensure that the transaction can be finally committed. So if we first ensure, then the transaction will be finally committed and the new value of the transaction of the particular variable has been written over the media. The following cases may be arise in the case of failure. Like for example, failure occurs before the log file is written to the stable storage or before the transaction completes, maybe. And the failure occurs after the log file is written to the stable storage or the log file being written to the stable storage. There are two conditions. So in the first condition, the log file is simply ignored as the transaction has not affected the database because everything is written in the log file. Then the database is not completed. The transaction is not completed. So the log file is simply ignored. It will not affect the transaction or the value of any variable stored in the hard disk. And the transaction is restarted by the recovery process. What is the recovery process? Read the transaction from the very beginning. What is the first command? What is the second command? What is the third command? This is how. But if the failure occurs after the log file is written to the stable storage or while the log file is being written to the storage, then what we have to do? The system uses a redo operation. First, the log file has been written. Everything has been written. In this, failure occurs before the log is written. In this, log file is written, but before the log written, failures occurs. So nothing has been stored in log file. But in this, the log file has been created and everything is stored in the log file. So what it does, if the failure has happened after the log file created, then it simply uses redo the transaction again. So this is how there are two types of failure: before the log file has been created or after the log file has been created, the failure occurs. In both cases, in this cases, the log file has been discarded or maybe ignored, or in this, the log file, the recovery system uses simply redo command. Like for example, this one. So this is the same, nothing new. So maybe this is repeated. So consider the following scenario for the system crashes. In this case, okay. So there are different cases to commit this transaction. What are the stages? Number one, system crashes just after the log record T0 B 2000 2050. It means here the system crashes. So what is done? If the system crashes, it means for write B to as written in the stable storage to log the system appear as follows this. And now the system fails. When the system restart, no redo action needed to be taken since no commit record appears because there is no commit operation. The system do not committed any value. The system has not write any value either for A or for B. The value of A and B remains same. It means the previous value has been recovered. Log records is for the incomplete transaction are deleted from the log file because the system has not committed yet. The second one, the system crashes just after the log 1 C for the write of the T1 has been written to the stable storage. Like for example, in this case. So, and the system shut down unexpectedly. When the system restart, what will it do? Because there is a commit operation. So this has been redo again because the transaction has been completed and the value of A and B has been revised. So the operation redo of T0 transaction is performed since both start T0 and commit T0 appeared in the log file. But what about the T1? What about the T1? T1 is not updated because it is not committed. So the previous value of C 700 is remain same. So it means in this case the transaction is ignored. So in this case T1 is ignored, but T0 has been redo the T0 transaction. The third case, the system crashes after the T1 committed. It means both transaction has been committed. both transaction T0 and T1. When the system restart, then redo T0 and redo T1. Both transaction has been to be redone because both transaction has been committed. So the new value of A is a 950, new value of B is 2050, and new value of C is a 600 should be reflected in your hard disk. So this is the recovery process of 3 different cases. Now comes on immediate database modification. This scheme allows update of an uncommitted transaction to be made to the disk before the transaction commit, that the transaction is still in the active state. Database modification written by the active transaction are called uncommitted transaction, and in the event of crash or failure, the system must use the old value field of the log record to store the modified data item to the value they had prior to the start of the transaction. So this is the example. The same example we have taken for the immediate database modification. The same example. This is the same example. So immediate modification technique, the undo and redo operation are applied. Undo and redo operation. You have seen that in the deferred database modification, only redo operation is there. Only redo. There is no undo operation. Because if the log file is not created, we can simply ignore the file. If the log file is created and a committed transaction has been done, then redo the transaction. But in immediate modification technique, there will be undo and redo, both command should be applied. For all transaction Tk in L that have Tk committed in the log execute, then undo Tk. K is the transaction number. We can undo the transaction. For all transaction for which Tk committed appears in the log file, then execute, redo, execute. So what does it mean? In the log, if the particular commit has been appeared in the log file, then we have to do undo transaction. If the transaction is committed, if the transaction is committed in the hard disk, appears in the log execute, it means has been completed the transaction, then we have to do a redo transaction. So what is in this? In this only log file is created. In this, the log file has been reflected in the hard disk also. So if the log file has been executed, then we have to do a redo command. Otherwise, we can simply undo the transaction. So for deferred modification technique, only the redo operation is applied, and for the immediate modification, we have to apply undo and redo both. Okay. So these are two procedures, undo and redo. Undo transaction, it means restore the value of data item that is updated by the TI to the old values. And redo, the new values has been updated in the transaction. After a failure has been occurred in the system, recovers, the recovery manager consulted to the log to determine which transaction need to be redone and which transaction do we need undone. Okay. So we have to check that what type of transaction we can undo or redo. TI needs to be undone if the log contains the record TI start but does not contain the record TI committed. It means the transaction should be undone or undo. But if the transaction log contains both record TI start and commit, so it should be redone, redo. So if there is no commit command, we have to apply undo operation. If there is a commit command, then we have to do redo operation. But in default database, we can simply ignore in the first case, and in second case, we have to redo transaction. So in immediate, in the first case, we have to undo the transaction. Okay. Like for example, this is the case. So does the transaction fail at this point? There is no commit operation after T0B 2000 and 2050, and the system crashes. So in this case, T0 undo operation should be performed. When the system restart, undo T0 should be performed so that the older value of A and B will be there. In the second case, when the transaction failure at this point, then redo this transaction and undo this transaction because there is no commit operation in the T1. So redo the transaction T0, undo T1, so that the new value of A and B should be reflected in your database, but the older value of C should be reflected because there is no commit command of T1. In the third case, when the transaction failure in the last commit, after commit operation, so both T0 and T1 transaction has been completed, both transaction. So there is no undo. We have to do redo T0 and redo T1. Both transactions should be redo again, so that the newer value of A, B and C should be reflected in our hard disk or in our storage. So this is the simple procedure to recover our database, a deferred and immediate modification. But what if a longer transaction has been there, there is a longer file is there, so we have to redo or undo to a certain level, to a certain point. So there are some checkpoints. We have to apply checkpoint that after 5 command, we have to apply that this is the my state where we can, if there is a transaction, so we can undo the transaction to this state. So we have to apply some checkpoints. So when the system failure occurs, the log needs to be consulted for the transaction that need to be redone or undone. So at what level? The level decided by the checkpoint. It means searching to the entire database for the search process in the time consuming, the transactions that need to be redone have already written to their update database, or to reduce the type of these checkpoints are introduced. We do not have to redo or we do not have to undo, we do not have to read the complete transaction. We have to do a certain level, that this level we have to redo, we have to undo. So checkpoints are introduced. So consider, for example, there is a T0, T1, T2 and T100 execution in a sequence. There are longer transactions. Recently, we have studied only T0 and T1. So deferred or immediate database we have checked. But there are transactions, serial transaction T0 to T100. So if it fails at T100, so if we are using deferred or immediate, what we have to do? We have to undo the old transaction or redo the transaction again and again and again. Each and every transaction has been redone. No. So we have to apply checkpoint to a certain level. Like for example, the most recent checkpoint is a T67. So it means T6 up to T66 has been completed successfully. We do not need to read, undo or redo the transaction up to T66. So we have to roll back the transaction to 67 only. Now only the transaction T67, 68 to 100 need to be discovered, need to be recovered. So this is the importance, or this is the beauty of this checkpoint. So this is a simple example of checkpoint, like for example T1, T2, T3, T4. This can be a checkpoint at T2 level, this can be a checkpoint at T4 and so on and so on. Recovery for concurrent transaction. The recovery system deferred update and immediate update handle the transaction to an environment where transaction execute serially. And log-based recovery algorithm can be executed to handle transaction running concurrently. And there are two lists maintained by the recovery system. One is active and another is committed. All the active transactions since the last checkpoint are entered in the active state, and all the committed transactions are entered to the committed state. So last checkpoint should be there where there is an active state, and all the committed transaction entered in the committed state. So immediate update algorithm. During the recovery process, the right operation of all the transactions in the commit list are to be redone in order to which they were written in the log file. Or the right update operation of all transactions in the active list are undone in the reverse order in which they were written in the log file. So redone in the order which they are written in log file, and undo or reverse are undone in the reverse order. Okay, so this is most important. Like for example, consider the transaction T1 to T5 executing concurrently. So checkpoint is made at TC, this checkpoint at this point, and system failed at the TF. System failed. So if we want to do Undo. So undo, it means the reverse order. And if we want to redo the transaction, so redo in this sequence. Okay, understand? So T1 and T2 are present in the committed state, are redone. T1 and T2. This should be redo because it is already committed. This is a checkpoint, but maybe this is committed at this level. So T1, T2 are then committed state. T4, T5 present in the active list are to be undone. T4 and T5 because at this point, and at this point, we have the transaction failure and we do not understand whether committed operation has been applied or not applied. So these two transactions should be undone. Okay. So this should be undone. And T1 committed before the last checkpoint, hence it may not be redone. It may be committed. So this should not be redo again. This is the beauty of checkpoint. The checkpoint applied at this point, so T2 transaction should be redo, but T1 not. Okay. So in deferred update algorithm, at the time of recovery, the transaction in the active state simply ignored, as the transaction have not affected the database and not need to be undone. And the transaction in the committed state are to be redone again. So this is another concept, shadow paging. Shadow paging is an alternate approach of the recovery, alternate approach to the log-based recovery, and it do not require any type of log file. It requires the shadow paging concept, and it is basically useful in the transactions that are executed serially. Not one transaction is active at a time. So this technique involves making different copies called shadow copies of the database. Shadow copies are the same copies. Like for example, if we are creating the log file, it means the log file contains all the commands, all the syntaxes serially. But in shadow paging, what we are doing, the same copy has been created in the hard disk. Same copy. Okay, so database is considered made up of a fixed size of unit of storage space called pages, and page table maintained for the pages. Like you have already stated that in virtual memory or in cache memory, there is a mapping between the RAM or hard disk or virtual memory or the cache memory. So the page table has been created to show that this particular database has been mapped with this, and this is the shadow paging of this. So a page table with the n entries corresponding to the n pages in the database is constructed, in which the ith entry in the page table point to the ith database page on the disk. So there are two page tables in the maintained. One is current page table and the second one is shadow page table. So current page table point to the most recent databases, most recent, and shadow page table is saved and the current page table is used by the transaction. When the transaction starts, the current page table is copied to the shadow page table, and the shadow page table is never modified during the execution of the transaction. Initially, both tables are identical until unless there should be any transaction committed or there should be any transaction completed. So this is a diagram of shadow page table. Like for example, this is the page table and this is the pages on disk, different pages. And these page tables are referred to these different pages on the disk. Okay. So this is an example of shadow paging. Like these are the pages reflected on these pages on the table. So this is current page table. It means 1 refer to 1 refer to 1. It means this is a shadow page table. This is current page table. The same copy has been reflected from the pages on the disk. Yes. Of course, this require additional space in the storage device. So, where we are using this type of recovery system, where we are seeing that the database is too important, and we do not want any type of crashes. And if the system crash or the hard disk failure or any type of mishappening has been done, so we do not want that this log file has been destroyed. So we cannot recover the database. So better to create the shadow pages. Yes, if it obviously require additional space, additional storage. In case of failure, the current page table is discarded, and the disk blocks containing the new pages are to be released. The previous systems of database prior to the transaction can be recovered from the shadow page table, because shadow page table, shadow page or the current are both are same. In case then there is no failure and the transaction is committed, then the shadow page table is completely discarded and it is deleted from the hard disk, and the all old pages released. So the advantage of shadow paging over log-based scheme: no overhead of writing log record, and recovery overhead is negligible. So these are different disadvantage of shadow page table, and because it is very expensive, data gets fragmented. After every transaction complete, the database page contain older version of modification database need to be garbage collectively, and it is easy to extend log file schemas. So these are some references of this. So today we have discussed a different recovery system. In the next lecture, we will discuss more about the database concepts. Thank you very much.